Today we're going to learn about modeling linear functions and also review solving systems of two-variable equations with elimination. Problem 1. A company purchases a copier for $12,000. The spreadsheet shows how the copier depreciates over an 8-year period. Part A. Write a linear function to represent the value v of the copier as a function of the number t years. The cost up front, $12,000, is going to be your y-intercept. For our linear function, we're going to use y equals mx plus b form. Let's write our function in the form y equals mx plus b. So we'll need the y-intercept and the slope. The y-intercept can be seen here, 0, 12,000. So b is 12,000. The slope is the rate of change between 2 points. I'll pick the first 2 points. This makes our slope negative 1,250. So our linear function is y equals negative 1,250x plus 12,000. Sketch a graph of the function. Explain why this type of depreciation is called straight line depreciation. First, be sure to label your axes. Our x-axis is actually the t-axis in this case, and the y-axis is labeled v. For the t-axis, I'm going to go by 1 unit each. For the v-axis, I'll go by 2,000. Now go ahead and graph your points. Why do you think this is called straight line depreciation? The function value decreases at a constant rate, forming a decreasing linear function model. That is why it's called straight line depreciation. Interpret the slope of the graph in the context of the problem. Remember, the y-axis is the value of the copier and the x-axis is time in t years. The value of the copier depreciates or decreases by $1,250 per year. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. The y-intercept for this line is 0. The slope is rise 24, run 5. We could also use the slope formula to find the slope between 524 and 0, 0. So our equation is y equals 24 over 5x. What does the slope mean in context of the problem? If slope is rise over run, the slope is the distance traveled divided by the time interval. When we reduce 24 over 5, we get 4.8. So the asteroid travels at a constant rate of 24 miles every 5 seconds, or approximately 4.8 miles per second. This rate is constant because we have a linear function. Part B, the asteroid came within 17,200 miles of Earth in February of 2013. About how long does it take the asteroid to travel that distance? So now we're given a distance and we want to know the length of time it would take. The distance is represented by the y-axis. So let's plug in 17,200 in for y in our linear function and solve for x. For the asteroid to travel the 17,200 miles between where it is and Earth would take about 3,583 seconds. I don't really know how much time that is. That's a lot of seconds. But I do know that 3,600 or 3,600 seconds is an hour. So yeah, this would be about an hour that it would take to travel. For rates, they like to use it per 1 unit. So how many units over 1 unit of time rather than multiple units of time. Number 3, 2 prom venues charge a rental fee plus a fee per student. The table shows the total costs for different numbers of students at Lakeside Inn. The total cost y in dollars for X students at Sunview Resort is represented by the equation y equals 10x plus 600. Which venue charges less per student? I'm going to start by writing the table as an equation. I don't have a y-intercept, so let's find the slope between 2 points first. So I found that my slope is 12. I'm going to use point slope form to plug in a point and a slope and then simplify that to be slope intercept form. So the equation that represents this table is y equals 12x plus 300. Which venue charges less per student? Per student is going to be your slope. So Sunview is charging less per student. How many students must attend for the total costs to be the same? So how many x in order for the y's to be equal? What we're going to do here is make the y's equal to one another and solve for x. Continue solving. Therefore, 150 students must attend for the cost of each venue to be the same. For number 4, solve the following system of equations using elimination. Elimination means we're going to add or subtract the equations together. I would rather add an equation that I've multiplied by -1 than have to remember to subtract negatives, perhaps, which means I always multiply by a negative and add rather than thinking about subtraction. If I added these two equations together, I would get 3x plus 9y equals 0. No variable has been eliminated, so what you need to do is multiply one of these equations by a factor that will then, when we add the two equations, eliminate either the x variable or the y variable. So I see that x here has a coefficient of 1 that makes it really easy to multiply into whatever we want it to be, and this has a coefficient of +2. So I want my first equation to now have a coefficient of -2, so when I add it with +2, it becomes 0. This new version of equation 1 is equivalent to the previous equation 1. Now I can add, and I have -3y equals -6. Now I can solve for y to get y equals 2. Plug that in to either of the original equations to solve for x when y equals 2. When y is 2, x is -6. My solution will be written as an xy coordinate point, but before I box that in or highlight it, I want to check to see if this is truly the solution for the system of equations. Go ahead and plug in -6 for x and 2 for y into each equation, and if both are made true by this solution, then it is our solution point. Now that we have verified that this is the solution, -6, 2, we will highlight to show that it is the answer.